Alright, so we are going to multiply these two together. And remember, when you're multiplying a binomial times a binomial, we need to take square root of 5 times 2 square root of 5 first. And remember, you multiply what's on the outside, so I would take 1 times 2, which is 2, and then square root of 5 times square root of 5, that would be square root of 25. I would then take 1 square root of 5 and I would distribute that to -1. So there's no square root here, so I would just take -1 times 1, and that would be -1 square root of 5. So I distributed that to both. Now I'm going to go to -5 and distribute here. So I would take -5 times 2, but you do not take -5 times square root of 5. You only take -5 times 2. That would be -10 square root of 5. And then finally, I would take -5 times -1, and -5 times -1 is plus 5. Now let's simplify. Square root of 25 is 5. So I got 2 times 5, that'd make that 10. And then I see also that these two are both radical 5s. So if I take -1 square root of 5 minus 10 square root of 5, that'd be -11 square root of 5s. And then I have plus 5. Then I see that 10 plus 5 are like terms, so 10 plus 5 is 25. And I would leave that part alone. So I get 25 minus 11 square root of 5. Let's go to the next one. So I'm going to take 2 square root of 3. I'm going to take this term times this term. So I'm multiplying those. So 2 times 5 is 10. And square root of 3 times square root of 3 is square root of 9. I'm then going to take, so just for our notes, I took this times this. Now I'm going to take this and distribute it to the other one. So 2 times 2, that's 4. And 3 times 4, that's 12. I would then take square root of 5 and distribute that to 5 square root of 3. Remember, there's like a 1 there if you need it. 1 times 5 is 5. 5 times 3 is 15. So you just get plus square root of 5 square root of 15. And finally, I would take square root of 5 times 2 square root of 4. So 1 times 2, that'd be 2. And then 5 times 4 would be 20. Let's see, square root of 9 is 3. 3 times 10 is 30. So this would become 30. I could reduce this. Remember, 12 12, and I'm going to write that out. So 12, I could break 12 up into a perfect square. 12 is the same thing as 4 times 3. But the square root of 4 is 2, and 2 times 4 is 8, so that would just become 8 square root of 3. And let's not forget my 30. Let's see. 15 breaks into 5 times 3. There's nothing I could do with that, so I'm just going to bring it down and write that as 5 square root of 15. And then here, I recognize that I could break that into 4 times 5. But the square root of 4 is 2, and 2 times 2 is 4, so I'd get 4 square root of 5. Now here's where I would check and I would make sure, can I reduce any more? I have a square root of 5, no other square root of 5s. A square root of 15, no other square root of 15. Square root of 3, no other square root of 3s. So this is actually its root. Number 8. Describe the transformation. So remember, negative 2, what does that do? That actually translates 2 units to the right. Okay, remember that minus, anything inside the radical goes left and right. And then what else is going on here? What else is going on is I have this plus 1. So if it's on the outside, that's up and down. So that's going to translate it 1 unit up. And they want us to graph, so let's just go out to Desmos real quick, and I'll show you. So the parent function would be cubed root of x. So that's what the parent looks like, right here. That's the parent. And now we're going to type that in. So how are those different? Notice what happened. This was shifted 2 units to the left. So see, we call that the vertex. 2 units to the left and 1 up. See, it went 2 over, 1 up. And now it's right here. So that's how I would say that. This red went 2 to the right and 1 up. What happened here? Well, the plus 1, that's going to translate, or use the word shift, translate 1 unit to the left. And I'll put that in blue to match the color. And then the 3, that's going to move it 3 units up. And then we have one more thing, and that would be the negative. And remember, the negative, that reflects it over the x-axis. And I don't have that color. That's going to reflect over the x-axis. So it's going to be flipped over, moved to the left 1, moved up 3. And you can go type that. So here's my parent, and what happened was I do x plus 1, x plus 3, so that should say plus 1, and that should say plus 3. And notice, right now it's been moved left 1, up 3, but then we're also going to flip it over. And it's just going to take that green and it's going to flip over the x-axis. Well, I should say not over the x-axis, but reflected vertically, or I guess that'd be horizontally. So yeah, it was reflected as well.